Now let's solve one more question. Determine the value of k so that the following function is continuous at x equal to 5, and the function f is given by f of x is equal to x square minus 25 upon x minus 5, where x is not equal to 5 and f of x is equal to k when x is equal to 5. And in the previous episodes, you have already learned that a given function is continuous at a point if and only the limit of the given function at the given point is equal to the value of the function at that point. So the given function will be continuous at x equal to 5 if and only limit x approaches 5, f of x is equal to the value of the function at the point x equal to 5 or f of 5. And as per the definition of the given function, if x is equal to 5, then f of x is equal to k. So that means f of 5 is equal to k. And now let's calculate the limit of the given function f of x at the point x equal to 5. Now limit x approaches 5, f of x is equal to, and now when x approaches 5, so that means x is either slightly greater than 5 or x is slightly less than 5, or in any way it is not equal to 5. And as per the definition of the given function, if x is not equal to 5, then in that case f of x is equal to x square minus 25 upon x minus 5. So now this limit can be also written as limit x approaches 5, x square minus 25 upon x minus 5. And now in the numerator, x square minus 25 can be also written as x square minus 5 square. And what's the value of a square minus b square? Now a square minus b square is equal to a plus b into a minus b. So that means x square minus 5 square can be also written as x minus 5 into x plus 5. So now this limit can be also written as x minus 5 into x plus 5 upon x minus 5. And finally, this expression becomes limit x approaches 5, x minus 5 into x plus 5 upon x minus 5 is equal to k. And now cancelling out x minus 5 from both numerator and the denominator. So finally we have limit x approaches 5, x plus 5 is equal to k, or we can also write it as k is equal to 5 plus 5, or k is equal to 10. So that means the value of k for which the given function f of x given by x square minus 25 upon x minus 5, where x is not equal to 5 and f of x is equal to k when x is equal to 5 is 10. Now let's solve one more question. Prove that the function f of x given by f of x is equal to a to the power 2x plus sin x into cos x, where a is greater than 0 is a continuous function. Now here the function f of x is given by a to the power 2x plus sin x into cos x. And here again you can see the function f of x is a sum of two functions, where the first function is a to the power 2x and the second one is sin x into cos x. And if we can prove that a to the power 2x as well as sin x into cos x are continuous function, then that will also prove that the function f of x is also a continuous function. Now our first function a to the power 2x can be also written as a to the power x into a to the power x, and now a is greater than 0. And from the theorem which you just learned in this episode, a to the power x is a continuous function where a is greater than 0. And a to the power x into a to the power x is also a continuous function because the product of two continuous function is also a continuous function. So that means our first function a to the power 2x is a continuous function. And the second function sin x into cos x. And here in the previous episodes you already learned that sin x as well as cos x are both continuous functions. And the product of two continuous function is also a continuous function. So that means the function sin x into cos x is also a continuous function. And now a to the power 2x and sin x into cos x are both continuous functions, and the sum of two continuous function is also a continuous function. So that means the function f of x given by a to the power 2x plus sin x into cos x, where a is greater than 0 is a continuous function. Now let's solve one more question. Find the value of k for which function f given by f of x is equal to sine of 1 upon x, where x is not equal to 0, and f of x is equal to k when x is equal to 0 is continuous at x equal to 0. Now again the given function will be continuous at x equal to 0 if and only the limit of the given function at the point x equal to 0 is equal to the value of the given function at the point x equal to 0, or in other words, if and only limit x approaches 0, f of x is equal to f of 0. So in this case, let's first calculate its limits. Now limit x approaches 0, f of x is equal to, now when x approaches 0, then that means x is not equal to 0. So when x is not equal to 0, then f of x is equal to sine of 1 upon x. So this limit can be also written as limit x approaches 0 sine of 1 upon x. And now when x approaches 0, then what will be the value of 1 upon x? When x approaches 0, then in the numerator we have 1 and in the denominator we have very small number close to 0. So 1 divided by a very small number will be equal to a very large number, or you can say it will be equal to infinity. So when limit x approaches 0, sine of 1 upon x will be a very large number or infinity. So it won't be a definite number. It won't be a fixed number or a definite number. So we won't have a definite number in this case. So we can say the limit of the given function when x approaches 0 doesn't exist. And now if its limit doesn't exist, then that means this function cannot be continuous. So there can be no value of k for which the given function will be a continuous function.